हेलो हेलो। हेलो। आवाज आ रही है? ओके। वर्क करिए। ये तो सबसे पहले देख लेते हैं किस कॉन्टेस्ट के बारे में डिस्कस किस कॉन्टेस्ट पे डिस्कशन करते हैं। जस्ट सेकेंड। तो लेट कोड कॉन्टेस्ट जो था 504 जो कि 31st मई को हुआ था, इस पर डिस्कशन स्टार्ट करते हैं। तो थोड़ा सा इन डेप्थ डिस्कशन करेंगे। क्या क्या हो सकता था, कुछ की मैंने भी अभी तक ऑप्टिमल नहीं लिखी, तो उसको भी ट्राई करेंगे ऑप्टिमाइज करने का। तो स्टार्ट करते हैं फर्स्ट क्वेश्चन से। तो फर्स्ट क्वेश्चन बेसिकली क्या था कि यू आर गिवन एन इंटीजर n, वी आर गिवन एन इंटीजर n. द स्कोर ऑफ n इज डिफाइंड एज द सम ऑफ d स्टार फ्रीक्वेंसी. मतलब हमें निकालना है स्कोर, और स्कोर है d स्टार फ्रीक्वेंसी ऑफ d over all distinct digits d, where frequency d denotes the number of times the digits d appears in n. Okay, so we have to calculate this for all distinct d, where frequency of d is the number of times it occurs in the number x, number n. All right. Just let me. Yes, that's better. So the next thing we know is, wait, mouse. All right. The next thing we know is we are gonna have to find the frequency of all digits, and as you know, there are only like 10 digits, which are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. First, we'll find the frequency of each digit, and then what we are gonna do is we are gonna multiply these, like multiply these and add all of these. We do the summation of all of these. Now, for finding here, this part is pretty obvious. Like there is not this is not hard to implement. Like we just create an frequency array or a map or an unordered map. Everything would work. However, this is the most like optimal thing, I would say, since we can just create a frequency of 10, which will store the frequency of all to 0 to 9. So this is the most appropriate thing for this question. Now the next thing is how we will find this. So this approach will be used quite widely. Like first we create 10 variable temp, which could be like temporary, and we initialize it as n. Then what we do is, suppose if we have 3, 2, 4, 1, how will we find the value of, I mean, how will we find the individual digits? So one thing we can do is, if you see the last digit is always numbers percentage d, matlab modulo d. Last digit is always n percentage t, modulo 10, sorry, my bad. The last digit will always be n modulo 10. After this, we can see we get 3241. First digit from right is 1. Now what we can do? So, in order to make this the last digit now, we simply shift this to like 3241. What we want is we want to shift all of them to one right places and remove this. So for that we can simply make it uh, like what we want is this to become 324.1, and since it is like we are storing as integer, so it will definitely round down and it will become 324. So we'll first take int t is equals to temporary modulo 10. This is our digit, and the next thing we do is we divide temporary is equals to temporary divided by 10. So we'll get this. At next step, this will become 32.4, which will be equal to 32. Then we'll get 3.2, which will be equal to 3. So at every point after this step will get us the digit, and either we could store all these digits in a vector. And for how long we have to do this? Like once this is 0.32, so this becomes 0. So at this point we have to stop, because this means that here at this point there is no digit. Thus we need to stop it right here. And we stop when temporary becomes 0. So what we'll do is um, we create a while loop while temporary, and then we do the operation we saw over here. And now either we can create a separate vector for storing the digits, or we can just uh, after finding out d, we simply do frequency of d plus plus. Now, since we have the frequency of all d, we'll just iterate an array, iterate the array frequency for int I is equals to 0 to I is equals to 9, and we'll create a sum, initialize, initialize it as 0, and sum plus is equals to frequency of d into d. The question asked us frequency of a into d, and here d is I, right? So he'll just write frequency of I star I. So that was it. And after all of this, we'll just return the sum, and this should work. So let's code this. First, we'll just create an temporary. We also initialize the frequency array. All right, while temp int is equals to temp percentage 10 m divided by equal to 10, and frequency of t plus plus. Now what we'll do is we'll iterate. Let's just take it as t. T should be less than 10, t plus plus, and here we create an answer. Int sum is equals to 0. Now what we'll do is we add sum plus is equals to t star frequency of t. So this is it, whatever we have discussed, and we'll just return sum, and this should work. Okay, so this works. And sometimes you'll see like memory beats 50%. Don't focus on it, but what I usually do is like you could sometimes try submitting it again and all. But one more thing you can do over here is we actually don't need the frequency array if you see. We are actually adding every time frequency is seen, like we are just adding D. You look closely. This is just equal to the sum of digit if you look closely. So this part is actually this is just this. Sometimes these are small observations which we could see from light of a table. How they just actually have a this is what as you mentioned from this point. Like, if you even want to optimize other makes although it is not generally can be used use the common data, whatever it is. Sure, sure. Okay. Okay. This thing can okay, so the next question, right? Um, that's the next part. Like of these wishes and of things to be shit. Yeah, one thing is part of it. Was kind of stuff. Express this. This. Another device. So, right. So now we'll discuss question number two. For question number two, we can see we are given a 2D integer array, which has two things. First is items, like which name is item, and it has two things. The first element is the factor I, and the second is the price I. All right. Next, this represent the ith item. Like there are items dot size items in total. I mean, if items is of size n, there are total n items, and this is the ith item. You are also given an integer budget. Also, we are given a budget. My bad. There are unlimited copies of each item available for uh, purchase. So, like we have infinite copies. We can purchase as many of these as we want. You may buy any number of copies of any item such that the total cost of the purchased copies is at most budget. Now, what we are saying is we can buy, suppose these are the items we see. Uh, the price, so P1 plus P2 plus P3 plus P4. What the question is telling us that suppose we bought A1 times these and A2 times these, A3 times these, A4 times these. So all of the sum should be less than or equal to the budget allotted to us. Now, as we can see, uh, if you don't say like this is already looking like a typical knapsack problem, like if you don't know knapsack, so it's a idea in which suppose we have a capacity of uh, suppose we have a capacity of V and we are given n items whose weight are Wi each like W1, W2, W3 and W4. And also we are given a score or points, suppose points P1, P2, P3, P4. So what knapsack is that we want to use fill this V space, suppose a basket or whatever, with all these items such that this is the weight 1, weight 2, weight 1, weight 2, weight 3, weight 4, weight 5. These are all the weights. And all of this sum should not exceed V. And we have the maximum possible points. So that is what a knapsack is. Uh, so if we change the question slang, if we read the question after this part, so after buying, there is a additional thing other than knapsack that we'll study now. After buying items, you may receive free copies according to the following rules. For each item I that you bought, at least one copy. If you bought any non-zero number of copies of this, like if we bought A1 copies of E1, you receive one free copy of every item J. Of every item J, we receive one free copy such that, first of all, J is not equal to I and factor of I divides factor of J. So what the question is telling us that the factor of that item, if this times any x or where x is a integer is equal to factor of another number. So we'll get this product free along with this for the first time we purchase this. Like if we reach an item, suppose we reach an item I I okay, suppose it's item 2. Let's write this in a more cleaner way. Okay, suppose we reach item I. So if it is 2 and there are other with 4, 6, 8, these are other factors like we have 2, 4, this is our first, we have 4, 6, we have 6, 3, we have 8 and 9. So for this 2, how many factors j are divided by this 2? So what we find is this, this and this. So if we buy the first copy of this for technically for price 4, we pay price 4 and it looks like we should receive one copy, but we receive 3 free copies for the first time when we purchase this. And for the second time and second onwards, we'll pay price 4, but we'll receive one copy. Same goes for this. So what we'll do is we take 4 and we see this is not, but this is true. So when we buy item 4, we receive, let's write 4. Here we'll write 2, 6 will write 1 and 8 will write 1. So these are the number of copies we receive when we buy them for the first time, and this is the price we pay every time. Okay, so now I think the question makes a little more sense that, mm, okay, also, this is one such question where we cannot try greedily. Like, if you see, first we'll fill all boxes with a maximum ratio, like price to cost ratio. I mean, what am I saying? Items to cost ratio. Like, if we fill items to cost ratio first, so that will be an issue. So, suppose uh, if we have a budget of 200 and our first item is of price 101, and um let's suppose it's of 150, and the second is of 100, 51, and 49. Suppose this is it, and for 150 it is giving us 3 books. Let's not go with 3, I guess. Suppose 5 books. For 49 this is giving us just 1 book. 400, since this ratio is 30, it should be greater. Let's take 10 books. 10 books. And this is giving us 9 books. This is giving us 1 book. And let's take for 51, this is giving us 4 books. So, what is the item by cost ratio for this? Items by cost ratio is 150 divided by 10. So, we are getting effectively 15 first item for a 15 rupees cost. For this, it is rupees. Uh, I think we did some mistake, right? This 15 rupees. Here it should be, if we want to lower this from 15. Okay, actually, the examples I'm giving aren't properly matching idea. What example could we make? Somewhere, take this to be 9, and let's take it as all right. Yes, this should be a good example. We'll take 151. Hmm. Mhm. And for 151, and these both are of 50 and 50. For 151, this will give us 15. For 100, this will give us 9. For 50, this will give us 4. For 50, this will give us 4. Now, if we took the 151, because its cost ratio is approximately rupees 10, this is approximately rupees 11, this is rupees 12, and this is rupees 12 again. If we greedily took this, so we'll have 15 and we cannot buy anything. But if we leave it and we buy these, so that way we could have 9 plus 4 plus 4, that's 17. So 17 is greater. This, we cannot solve this greedily. So where greedy fails, in general, what ideas I'd have are brute force. Like, first we should think of brute force. Let's see the constraints. Items dot length is 100. Okay. All right, so here n is 100. I mean 1000, sorry. Bad. And the factors and their price are less than 1500, and the budget is also 1500. If you say like you try brute force trying all possible subsets of chosen ones, like uh, if we see there are n items, so first we have to choose which item will get, I mean, what will be the, which will be present, like which we are actually buying. Choosing that is either there is two possibilities, 0 or 1 for choosing or not choosing. This is also 0 and or 1. So like this, two possibilities. So the 2 की power n is just the time for choosing which ones are present and which ones are not. After that, we also have to define a number for multiplying this. Like if we chose this, we also need to define how many times are we are taking. Suppose if everyone had a price of 1, so we need to decide if it could be between 0, I mean 0 to n, for this also 0 to n, although some cases would definitely be invalid as it would surpass the budget. But you see, the worst case of all of this could be n to the power n, which I'm not like sure, but you can see this is exponential terms. I don't know what are the valid cases out of these. Like once we start assigning, like, okay, if we see a1 plus a2 plus a3 plus a4 plus a5, so these are the numbers. This is the budget, and for budget, and should be less than equal to budget, and we can assign like numbers, the quantity. Suppose it is x1, it is x2, x3. So this x1 has a range. Suppose we have 0 to 9. This is 0 to 9. So ultimately, like that, you understand it's kind of approaching exponential and really, really exponential. So the idea what we'll do is, next thing after brute force fails, what I think is usually a binary search on answer. So the idea behind binary search on answer is we try a value, we get a value, we try the value. If fails, value increase, yeah, decrease. If pass, value decrease or increase. Like which one is suiting more? Like if you want to find the minimum value which passes, if fails, we need to, like, we need to see what's the condition. Like if the range is as from 0 to 1e9. So does the question ask for a minimum or maximum value? Like if there is a point where x works, so we can prove that x plus 1, x plus 2 plus x plus 3, they all will certainly work. This is the idea of binary search. Idea of binary search is search for a value x if it satisfies we can prove plus 1, x plus 2, x plus 3, x plus 4, like either this case or x minus 1, x minus 2 up to 0 or whatever it is. These will definitely work. This is the basic idea of binary search on answer. Now, in this question, If we try binary search and answer, the first thought we'll get is number of books buy, we can buy. Suppose first we'll write 1E9, then we'll get 0. So here, and also the check should be of O of n, yeah, actual time complexity required upon log n, because this process of finding the number takes log n time. So we'll check it like this. Just a second. All right. So actually what I'm saying is that, like, if we want our solution to run in n log n and we are using binary search on answer, so this log n factor would go into finding this answer, and the O of n part will go into brute forcing it for a value, forcing it for a value, brute forcing the check. So if here we try for x, and we should see if we can buy x books or not. So that's actually not possible. Like, how will we see if we can buy x books or not? Thus, we discard binary search on answer. So after brute force binary search on answer, the third thing that comes to my mind is DP. Now, let's see what we are being asked, and can it fit into DP constraint? At any point, we have two choices, either to take it or skip it, right? If we are, suppose this is the array of the books, 1, 2, 3, 4, 5, 6. If we are at this index, so we have two options. Either we take this book and pay the price, and here suppose our budget is B or our budget is X. And if we take it, first of all, the price, uh, there is also condition, like if price of I should be less than equal to the budget at that point, we take it. So what happens is the value based on, if we are choosing this item for the first time, we define a value count, and if we are choosing it for the first, like, let me just write here first, and second, we write count plus. Now we'll go into another state. The another state we are seeing is where we'll stay at the same index, we'll have a budget of, and suppose we are at any point x, and we haven't chosen this book, whatever item, let's say item. I don't know why I was going into books. All right. So from our budget was, okay, this item, and our budget for next state will be x minus price I, and now we'll have the state as used. Earlier this was 0, like we haven't used this till now. Now it will be 1. So, and if this is the second term, we can simply add 1 and go into the state with the price, and still this would be 1. And if we skip it, we simply will go to the next index with the same one, and since we are visiting this index for the first time, it will be 0. So That was the idea we saw. Now the next thing we're gonna do is I don't like this. Okay, it was green for a reason. Okay. So this can be treated as DP state. Like now if we see we should create a DP of I comma x comma what is this used status. So I is 1000. This is 1500 and this is 2. If we multiply the complexity, so the total number of states we'll explore is this will be 3 into 10 to the power 6, and this should definitely run within the constraints since usually the constraints are 10 to the power 8, which is equal to 2 seconds if we assume 10 to the power 8 operations actually. So now what we'll do is we'll try this solution we created. Also before that, to find like which of how many multiples are present, we can simply brute force since there are 100. And for it to be easy, what we can do is suppose this is x. We try all multiples of x. Up to less than 1500 since no factor will be greater than 1500, and we'll store all of the factors in a either frequency array. Yes, we can store in a frequency array, and this will be of size 15. So we'll first create this, and next we'll initialize the number of factors of it which are present as -1. And why is it -1 is because when we will use this frequency array to store the frequency of all of these, like we'll store all of the factors I for I is equals to 0 to n minus 1. So you are seeing we'll also store the factor of this x. That is why we are initializing count as -1. So when we will add this, it will be neglected or eliminated from our answer. Next, what we'll do is we'll iterate through its multiple, and we see count plus is equals to frequency of 2 star x, and count plus is equals to frequency of 3 star x, and we'll continue this until we reach 1500. And now we can create a new vector. Suppose this vector is b, and in this vector we can store the score, count, whatever you can say. We can say count. This is the value we'll receive the first time, and its price. What we'll do is now apply the knapsack, and what will be the time complexity since uh, we have 100 of these, and worst cases we need to find x multiples, so the time complexity will be this, and this is obviously 1.5 into 10 to the power 6, so this should not cause an issue, although it can be more optimized, but that we'll see later on. First, this should be clear. I think after doing this, all of this, and at last we would return just calculation for the DP state. We will go in as 0, comma, budget, comma, uh, 0. That means we'll start at index 0. We'll initially have budget, the amount given in the question, and we haven't took any of the items present on the index one, so we can get the count, like the maximum possible out of it. So let's start to code it. So first what we say is we create an n of, it is items. Next we create a frequency array. It was of 1501. Then I'll just initialize it as 0. This is nothing, just the initialization of it as 0. Then we'll iterate all items for auto at the rate x items. And the first part was factor, right? So frequency of x of 0 plus plus. Now what next should we do? We should probably uh, create the vector which was storing knapsacks, like where we were storing the count comma price. So we'll create a new vector. Here we should just use it as pair, and for auto at the rate x items. But first we'll find int count is equals to -1. Now factor we are given in int f is equals to x of 0, right? For int I is equals to f, and no, for int I is equals to 1, I should be greater than, actually here we'll write I star, the, here what we are doing is we are checking if I star x should be less than equal to 1500, this value. So I star f 1500 and I plus plus, or we could have just initialized it as like this also, I is equals to f, and we could simply do this. Both are the same thing. So now what we'll do is, since it is 0 if there is no present, so, and we have also reduced this one, so now we can simply just iterate like this freely. Count plus is equals to frequency of I. This should work. Now we will push v dot push back count comma price I is x of 1. So we have created this. Now the next step is the DP part. So we'll just create a simple DP. Since we already know the constraints, we'll create int DP comma 1001 for I, 1501 for the factor, the budget, and 2 for used or unused. And here we'll simply return, first we need to fill it with -1. For filling it with -1, we'll simply dp of -1 comma size of dp. Next what we know is we'll create a recursion which will return us the best value, like if you know knapsack. So this is literally just knapsack in easy words. If you don't know knapsack, this is what we are doing. Now look closely the part where we are either taking it or not taking it. What are the things we need? Int I, int x, and int used. And we also need to pass the vectors. We need to access it over here. Okay, so first of all, if x is negative, we return a very big value, so the score would be invalid. We could also stop it. We could also stop ourselves from choosing it, but like this, I simply prefer this sometimes. Next, if we reach the end of the vector, if I is equals to v dot size, So what we'll do there is we'll simply return 0 since now there is nothing to select from and no choices, nothing. We'll simply return 0. Next, either we can memorize it first or we can simply just write the recursion as of now. Let's write the recursion. Int take is equals to uh, either let's just write 0. So if used, that means used is equals to 1, take is equals to 1 plus recursion of will stay at the same index, will reduce the price as v of I comma 1, and will take the status as used only and will pass v. Else we'll add the score we were amount we were intended, and we'll add it as same as this minus v I comma 1 comma 1 comma v, and we also have a int not take, and this will we'll just skipping is it, so we'll add nothing to the score. So we'll have I plus 1 and x, since we are not buying anything the budget will stay the same, and 0 because now we are visiting the next index for the first time, and v. And now what we have to actually store in the DP. The DP is for every I. If we reach at I comma x comma 1, so that should be the possible maximum possible value until we reach that index for all particular values. Like since this we are iterating in reverse. So like this is the recursion tree or something. Let's suppose this is actually a little more complicated, and this is first level, second, third, fourth. These are the I suppose. So what this will return is if we are at memoizing some I comma budget comma used status. So this is the maximum value possible by iterating all combinations of these. Like we always take the maximum of both of these, maximum of this plus this or this plus this, whatever is the best possible value. So that is what we are memoizing. So we need to return the maximum of both. Return maximum of take, comma, not take. And since this will be in exponential, like really, really exponential, in 2 to the power of n or maybe 2 to the power of n cross budget. So we'll simply memorize it. For memorizing, it's just if dp of I comma x comma used is not equal to -1, that means this state has been already calculated, and we can simply return that. And we're storing once we calculate this state as x comma used. So this is it. Okay. Okay, we were using pairs. We need to change all of these. Okay, here dot first dot second. Is there anything else? There are definitely more errors. Are we passing? Okay, we did not return anything. We started the recursion from 0, and currently we have budget as budget, and we haven't picked up this index yet, and we'll push V. Okay, there is definitely some error. Intake returning 1 with returning 0. y is equals to v dot size if x is right, is right. Let's try to see where it has gone wrong. First, see if this is being calculated right. Mm, we have 0, 1, 1, 0, 1, 1 is right. 2, 4, 6, 12 for 12, 0. So to here we are right. There shouldn't be any mistake. Budget is all right. X1 was the price, so we deducted x dot second, vi dot second every time we use it. Now, what's the issue? This is the budget, right? The budget is in 1500. Actually, that was not the factor, sorry. We took I, X, and U status, and we the issue CP of I or not take also we are clearly doing this. We are taking the maximum of take or not take, and we are returning integer. Answer is always zero, right? Are we using I plus 1? Yes, for 0 we'll iterate forward. Are we pushing? Yes, we have V. So definitely have a V. Yes, V 0, 1, 1, right? We have a V. Okay. Yes, we have it. Something is wrong in the recursion. We have budget initially will start at index 0. And if we're starting at index 0, if I is equals to V dot size, then we are returning 0. If x is 0 is greater than x, that means x is negative, we are returning a really big negative integer. So that should automatically filter out the cases where taking is not possible. And okay, take is equals. Still, something is wrong. Hmm, we are allowing it to stay on the same index to choose more of the if used take is equals to. Otherwise, hmm, a dot second is the price, right? Yes, the price should be subtracted from the budget. So where is the issue? EP three states, if them seems right. What is the wrong answer it is giving? It's giving 8 while it should give 10. For the second time we are adding as this. First time we're adding it as. Oh, okay, let's take more of these. In DP it's hard to just debug sometimes. DP of I comma, we used memset correctly. DP for size of DP. Here was a DP. Then we used return budget of 0 comma if x I v dot size. Everything looks right. Hmm, we forgot कि वो खुद तो खरीद ही रहे. अरे यार. Okay, this is really flat time complexity since we are using um, like recursion. And the issue was that we agree we weren't counting that, but we should count it once since we are actually purchasing the book. That should be counted once. We weren't counting, we were just counting the freebies. Hmm. So now let's try to memorize it. First, we'll just copy this logic as of now and we paste it here. Let's see what we can modify. Okay, so the things we can change are first we'll need to iterate for I. Okay, for int I is equals to 0 to I should be n. Uh, First let's do this as 0. Int j, i's are the indexes and we'll take just w is equals to 0. W should be greater than equal to budget I plus plus. Okay, so for every I we are trying all possible budget. But I think this would be way more convenient if we just do this. We will try mm, all possible value of W. Like we'll try to fill up the knapsack with all possible available things at that point and see if any possible combination could have resulted in a score which is more. So here the DP is representing the score and this is I should be uh, this is representing the weight with it and this is okay. Let's just start coding a little headache. Okay, and we also need to take care of k is equals to 1 and k is equals to 0. So I think I can manually code it. So if we are at an index and we are choosing it for the first time, that means k is equals to 1. Let's just write it as this. If uh, okay, so okay, let's just used is equals to 0 and used will maximum go up to 1. Used plus plus if w is greater than or equal to the, let's just uh fix these two quantities. Int price is equals to items I comma price was 1 and int the reward the score, so that let's I think it would be confusing to write it right. Yes, so we'll write it as I comma 0. This seems weird. We'll just write it as cost score. All right. So if W, should we just skip this part before? Yes, it is better if W is less than P. We'll just continue. Else dp of I comma used I comma W comma used is equal to if it is 1, then we have two cases possible. For used is equals to 1. I think this idea was bad using a for loop for it. You just take both cases. Like if it is 0, it is definitely coming from two previous cases, which could be at uh, uh, how did we reach to that state? Should be maximum of API comma W comma 0 comma uh, if we assume we took this, so we'll do EP of I comma, okay, this should be capital, comma, uh, okay, we were at previously this up before we bought it. Right, we will reach this when we bought it or whatever. Yes, we will reach this index after we bought it. So price and plus work, and if we are reaching that price, that means we have used it. And what will improve is score plus. Uh, should this be it? Also, if it is 1, then this will definitely be comma 0 comma 1 plus dp of I comma w minus p comma 1. So is there anything else we are doing? So this is, we can also leave it, right? All right, first let's see. This should be maximum of initially this. comma, mm, or or what else we could do? Since we are defining for this also, let's just define one more so we can actually reach beyond. We can reach beyond like this also. I comma w comma 0 is equals to comma 0. Comma dp of uh, why is it so hard to stabilize this one? See what we had in our code. In our code, if we are not taking, we're reaching to another index with the same budget. So here we should try going to the previous one, or maybe the next one. Hmm. Should this work? And in this, since we are iterating forward, so we should return dp of n comma budget comma, or should we iterate for all budgets? We'll see. There could be that we are not able to exhaust the whole budget. So int max is equals to 0, or int uh, w is equals to 0. So w should be less than equal to budget and w plus plus. Max is equals to maximum of max, comma dp of uh, n and w comma 0 comma dp of n and w comma 1. Shouldn't just discover everything we are asked. Let's just see once. Okay. Okay. This is also small. Stayed at the same index and we skipped. What is the issue? Mm, 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 mm. Okay, maybe it is I minus 1. Yes, I think it should be I minus. Oh, oh, maybe would be better if we should just. Let me say this. Did we define a base case when we were at -1? It should be 0. Don't think that would be at or if we have budget 0, we couldn't do anything. So that is obviously initialized at 0. Why are we even starting it as 0? Hmm. 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 We're reaching it for the first time. That means we were we would reach same with a reduced budget. Actually, why have we wrote this? We could skip also now. Why have we limited to both of these only? Like, this has obviously been, if not calculated, so we could take the previous index of, I mean, we could reach this state with either I minus 1 and 1 and I minus 1 and 0. So, and I think should write this before. Okay, right. So now this state would already be calculated. This would already be calculated. So this should work. Hmm. We arrived at this with 0. Could also be at hmm, we're still receiving output. as this. What would be the cause? Mm, greater than zero. You can simply copy the previous best. Like this was the part where we skip. So we can skip from this case also, from this case also. So this looks perfect. If the price is greater than V, W, we should definitely skip. If suppose it is present, so we'll first take it as max of itself, comma, score plus dp of I. Why not 0? And I is greater than 0. And we arrive at this. And now take the max. Okay, okay, okay. Mm, 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 mm. Is this the issue? All of this. Pi is greater than 0. We took the previous at 0. If W, if the weight we are at this is greater than this is also okay. We are taking either we could reach this by taking at the previous index. Should it be I minus 1? No, this. Wait. But we were filling n minus 1. Here we are checking n because here, okay. This is definitely a bug. Like, if not the bug, but this is one of them. Um, and we even how can we reach at 0 by taking that? This is wrong. Definitely wrong. Now this could be taken with two values, either this or we are taking it for the second time. 4 plus dp of I w minus b, and we took it for the first time. Oh, this doesn't work. I'm cooked. The How are we getting such a big answer? More than full. Mm, I think at this point it's just too much. Till here it was obviously right. Now either this or this. This is definitely right. I mean, there's no way this could be false. We can reach zero from two possible options, either with W uh, while the previous one was 1, or either with W when the previous one was 1, I minus 1 and 0. So if there is an issue, I think it should be in this part. This was the second take. Definitely it would be this. Fuck my life. Fuck. Okay, now maybe we can just optimize it since at every step we just need the previous one dp of I minus 1. So what we'll simply do is we'll reduce it to just this part. And since we are requiring the dp of I minus 1, So our I minus 1 should be calculated for the value uh, I minus 1 should be calculated for a lower value. Okay, I should be calculated. So is in the right direction because we already need this. And we should have calculated I minus 1 beforehand for the same W. So I think this is the right way of doing this. So if we just not this. Mm, Oh, we were calculating dp of I minus 1 before, so here also we are calculating dp of w comma 0 to dp of w comma 1 comma dp of w comma 0. Right, this is the skipping part, so this should be right still. And this part, one can only be reached from that point only. So either on the same index This should definitely work. Like, if this is not working, I think the structure is flawed. I think now we can obviously use I minus 1 because I minus 1 would have definitely be calculated. Yes. I don't think this cannot be optimized any further. Hmm. Like maybe there are, but uh, yeah, I see. Got it. They are changing this logic. Okay, but let's stick to this. Now let's go to the third question. So this is actually the same question. The only difference is this time. Oh, wait a minute. All right. So this time, firstly, the constraints are changed. So now the let's see the constraints. N is 10 to the power 5, and price and budget are factor is equal to n. It means and budget and price are oh, if the constraints were these and the question would have been same, that would be an issue because that is basically unbounded knapsack and it cannot be solved in OFN or it requires the budget or the capacity part that would have been issue. But there's a catch. Like previous times, if we buy one copy of a book, we get all the freebies along with it. But this time, if we buy X copies of the book, we will get max minimum of X comma uh, count freebies. That is the issue. Also, this time there is a catch that since uh, as we can see the factor is to 10 QR 5. So we cannot simply iterate for all factors because if all the factors are suppose 1 and will iterate up to 10 to the power 5. So that will be 10 to the power 5 into 10 to the power 5 and it will become 10 to the power 10 and it will give clearly. Hello भाई. रवि राज सुनार. Hello भाई. वेलकम टू द चैट भाई। कैसे हो? ऑलराइट, तो अपन डिस्कस कर रहे थे कि कैसे इस पॉइंट पे अपन आ, इसको अवॉइड कर सकते हैं। तो ये कब हो रहा है? जब अपन से वन के मल्टीपल्स बार बार पूछे जाएंगे, या सपोज टू के मल्टीपल्स बार बार पूछे जाएंगे, तो भी इफेक्टिवली 10 की पावर 5 इंटू 10 की पावर 5/2, क्योंकि इतने टू के मल्टीपल्स होंगे ये होगा। तो अगर अपन सबके मल्टीपल्स पहले एक बार स्टोर कर दें 1 से लेके 1e5 तक, तो उसमें क्या टाइम लगेगा? लेट्स सी। तो 1 से लेके 1e5 तक जाएंगे अपन, और 1 के लिए अपन ने कितने फैक्टर्स होंगे? 1e5। 2 के लिए कितने होंगे? 1e5/2। एंड वेट जस्ट सिमिलरली 3 के लिए होंगे 1e5/3। 4 के लिए 1e5/4। तो इफ यू लुक क्लोजली, तो जो टोटल फैक्टर्स अपने बनेंगे 1e5 के लिए, हर एक नंबर के पॉसिबल मल्टीपल्स इस रेंज में, उसका फॉर्मूला बनेगा 1 + 1/2 +1/3 +1/4 up to 1/n. So this simplifies to log n, and here this is n, so obviously n log n. So we can calculate all the multiples present in the array in n log n time. And now the issue is how we'll see how many to freebies to take. So if you notice closely, if you buy one copy of a mm, whatever it was item, and you get one as free, here we'll get at max one at free. Do you see here? Actually, we are getting two books for the price of one. First of all, if there was no such book or no such item, the maximum you can buy is budget divided by minimum cost. Right. But due to some things being free, like there are several free options. So like this price is effectively being treated as price by two up to a particular value. So it might go below minimum cost. And since it is going below minimum cost, what we see is that suppose the minimum cost was 3, 4, 6, and 8. These were the costs initially. And this book is offering two copies. Like if these are the prices, not the factors. So that changes how we see these. If these were the factors, so this would give us one book and this would also give us one book free. But since these are the prices, so if suppose this one had a count of 2, that means it had two factors. So if we are using it, buying the first copy for a price of 4, so we are actually getting two copies for just fourth price. So the effective price is 2. So you see this actually turned out to be better. We actually have two copies of worth rupees, two items of worth rupees 2. So we'll obviously go with the greedy part here, selecting these two before. And if suppose we are getting one more free, so we'll buy this again. And now we'll just be using 8 rupees and we'll get 4 copies. So now since this is finished, now we will move to this. And now for since this is actually 6/2 is also equal to 3, so there is no point in buying these pairs. We'll just go to 3 and we'll buy all with the remaining budget. This is the simple trick. So what we'll do is we calculate again the count and we'll push them into a vector and sort to get the maximum value for two books. And we'll buy those two books as long as, like you see here, the cost we are paying is actually, l- let's assume initially we are buying books in pairs of two, I mean items in pair of two. Yeah. So initially we are buying items in pair of two. So buying in pair of two means that if we use the minimum one, so we'll play 2 into minimum cost. Otherwise, we are playing just the price hike. And this we can do as long as our budget allows and the capacity. Like if there are 6 free books with it, so that will mean that we can buy at most 12 books. Note this is 6 free and not the 6 books we are getting. These are a little different. So we can buy at most 12 books for this discounted price for 2 books. And once all of this, like initially into mine minimum is less than or equal to price hike, we'll just start buying one book. Then that one book will buy at minimum cost and we'll use all our budget for it. These are the this is the number of books we'll buy in one pair, and these are the ones we'll buy into pair of two. So I think this should be easy. So we'll create a frequency array and just initialize. No, I think to initialize. Next, what we'll do is we'll iterate for for int I is equals to 0 or okay, we'll actually start from 1 because the multiples of 0 are absurd. Next, okay, also before that, mm, oh, no, I think, should we? What are the factors actually present? So this should be, okay, let's make two vectors, count and frequency. So first we'll just push all the frequency of all the factors occurring in this particular thing. Of x 0 plus plus, and we'll initialize this count also as 0. Now it should be pretty like obvious. We'll start at like, now we can write it as frequency of wave, but Let's just count I plus is equals to frequency of j. Think this is it. Our count uh, is made. Now, for simply, we create a new, okay, I am writing over here. We create a new vector for auto at the red x for all items. We push, we were pushing the count first. So count of x of 0, comma x of 1. Then the next part was simply sorting the vector. Also, maybe we should just find the minimum price over here. And minimum is equals to 1 like infinite. And minimum minus equals to minimum of mine comma x of 1. And now we just have to sort based on the prices. Obviously, if it is offering some CD, we have to look closely at what is the price attached to this auto accelerator, auto accelerator, and this return without finish. I didn't by default it would be this number. Okay, we're not another price only. Just realize it's the years. Now we like it, but if you have and you don't you haven't stored on it, and you will store it finish price. Now we will like it, but answer with HTTP while always estimate it or we have stored it as a clear. Right. So let's see that specific additional UI without push and in HTTP dot if price is greater than or equal to start to into minimum people. We can buy and now we can buy is minimum of capacity. How much budget related by budget related by price. Right. So since we can buy double of these, right? So we can buy double of these, double of this, we just and set less negotiable to which the going to buy. And also we will change the filter minus HTTP buy and once we go out of this, we will still add answer. Let's give it to budget right the time. We should return now.
it for the rights. To do let's see. Since the frequency is the TV ones, so we should have this. Oh, I don't understand. We got 13, but the answer was 13. It's 8, 5, because the price. Right. Um, they are also initializing the frequency of test directory. The count is directory because every value their count is actually the previous targeting. And the directory should not be if the items equals to the capacity and certain voltage to be started. That means the destiny by starting in one person. Yes, what you can really challenge. Yes, clearly how the disorder capacity and as basically sees meditation. Like basically, we are pushing repeatedly frequency of change is zero and it is a reverse to frequency of change. Watch price is greater than 20 slash Mm.
This will definitely sort in descending order, so this should not be the issue. Where is the issue? We want smaller price first. Uh, This case should be over. Uh, yeah, क्या 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 क्यों इतना हाँ, एक और गलत हो गया। अरे अच्छा, ये तो अब चेंज कर दिया ना मैंने। क्या कैसे कर लेता हूँ ऐसी गलतियाँ। हम्म, इतना गंदा कैसे आ रहा है टाइम कॉम्प्लेक्सिटी। कहाँ लग गई ऐसी टाइम। फैक्टर्स निकालने में क्या। हम्म, was there a faster way? Okay, people have just used mx as the maximum one. Like you could just frequency of n and then count of n, n, and this should, okay, it should be n plus 1 actually. Relax. Uh, n plus 1. All right. Now the last question. Lexicographically maximum array. Max array. Like theoretically, this should have been hard, but I felt like 2, 3, 4 were all equally hard. Like if someone hasn't studied, doesn't know knapsack, like it would be a little hard. And in general, DP is considered hard by many people. So that could have been the reason. Like, B will also feel. And so we see we need to find like so graphically maximum max array. What this is. You are given an integer array nums. Alright. Here we got nums. It's an array. And you must construct an array result by repeatedly performing the following operations until nums becomes empty. So we need to perform an operation. Let's see. We choose an integer k such that K is, oh, why is it host touching? Just, okay, this is better, right? So we choose at a point K where K is between 1 to n. Then what we do, we compute the max of first K elements. We take the max and we append this max to result dot push back max, and then we remove these. Now we just got K to n, and now we can do this repeatedly until this array exhausts. And the thing we need to do is we need to create this result array as lexicographically maximum. So in array terms, let's see what is lexicographically maximum. Suppose if we have 1, 2, 3 and 1, 3, 2. So for the first index where they differ in value, the greater one is lexicographically greater. This is the first rule. And suppose if they are the same for all possible indexes, so the one which is greater in size will be the lexicographically greater. So it's kind of like string, not much different. So like this question is kind of a competitive programming question because it expects you to do all of this in O of n. That's the hard part about the question. Here we need to work with observations. So firstly we'll see like we need to maximize our max. All right. So if suppose we have an array like, so we see at this point our max becomes 5. After this, our max stays as 5. There is not any difference. Since there is not much difference, we can simply just take out this part because the max stays 5 till the end, right? So we push 5 and delete this part. Next we see is we see the array stays as 4 or the max stays as 4 till the last, and it becomes 4 first at this point. So we can just delete this part. After that we can see simply 3 up to here, so we can delete this part. We can see 2 up to here, we can delete this part. We can see actually, sorry, we were saying max, not the maximum element. I mean, we were talking about max. So 5, 4, 3, 2, here 1. So we'll just get this. Because if we suppose break it over here or break it over here, it wouldn't be optimal. Because if we broke it over here, we wouldn't get 4. So our idea to create 5 here would definitely be destroyed, and we would get something like 6, 3. So that would destroy our lexicographically greatest. Now, what was my intuition in the contest was actually I did this after contest. Uh, the third question and second question took too much time, and about 10 minutes were left. I thought it's actually not worth it. So my idea was, how about if we first calculate the, uh, let's write it as max only, max of the entire array. Okay. And what we do is the first point where we reach max, what we do simply is we just break and push max. So now we got the max value. We were ultimately going to get the max value anyways, like the maximum value. We need to keep it here. But since we got it already over the first point, suppose here, so now we have the maximum elements to play with. And this could be proved like suppose if it is 0, 1, 2, 3 and 0, 0, 0, not 0. Suppose it is 1, 1, 1, 1, 1. So here first we'll obviously do this push 4. Now what we're doing is the max of remaining part is obviously 0, right? Since the max of remaining part is 0, so instead of combining it, why don't we break it every time? Because no matter what we do, we were gonna have to get 0 anyways. We break it into, so why not just break it every time we get the max? Since the max after this part becomes 0, so here max stays 0, here max stays zeros, here max stays zeros, here stays 0, here stays 0. So we're just pushing the max we currently have. Also, to find the max we get over here, what we do is, firstly, let me just tell you the O of max algorithm or O of n. To find the max of an array, the idea is simple. Like we maintain max as 0 and we use a map or a frequency array. And if, first of all, we do frequency of vi or whatever the digit is plus plus, we increment. And while the frequency of max is not equal to 0, we'll do max plus plus. So suppose if it was 3, 2, 1, 0. So max stays 0, max stays 0, max stays 0. Max is 0, but now the frequency of max is 1. So we go to 1. Now the frequency of 1 is again 1. So we go to 2. Similarly 3. Similarly 4. So we'll get the max of this array as 4. Okay. So this is the idea. Uh, and to calculate if currently we have got max or not. Like in this question, what we need to do is, like, suppose if we have our final max equals to suppose x and we know this exists, so we'll just create a map and store all frequencies in it of all elements. So if we know max is equals to x, so all x minus 1 values, all x minus 1 values will definitely have a non-zero frequency. Since max is equals to x, all values up to 0 to x minus 1 will have a non-zero frequency. And if suppose while iterating in the array at any point after reducing its frequency, we are reducing frequency like now frequency of vi minus minus. If any frequency turns 0, so the next max will be equal to that minimum of next max, comma, that particular element. Now, once we got our max as max, we erase this part. Why we erase this part? Because this has been used and we know that it is now we got max. And here calculate the max. Uh, what we are doing is, can we could use like that int frequency array, and we could just, you know, every time we reach over here, we could reset this. So since resetting will take time, like it will take O of n time. So if there are too many different elements, 1e5, like 1e5 for every reset, so we'll use a map, because map will take the total number of elements or the total number of unique elements over here. So for clearing the map, it will take O of these many elements. Like if here we see, like here if we are at index I, the clearing map will take O of I, and next time it will take O of j minus I. So ultimately this will be O of n clearing of map. Now, once we got the our max value, and how will we know we got the max value? We will simply do create an unordered map, and if the value in that unordered map that we are pushing, like we are not pushing it blindly, if the number, suppose we have an element x, uh no, element as vi, if element of vi is greater than, is less than max, our max of array, or the currently running max, then we'll push it in the map. Otherwise, else continue, we'll do nothing, because also vi is equals to max will not be in the array. That's obvious, because if it was in the array, so that would have definitely been the max plus one, our new minimum excluded integer. And now what we can say is, once there are all keys from 0 to max minus 1, that will mean that we have got all the values of 0 to max minus 1 in the subarray, which means we can do result dot pushback max, and now max is equals to next max, and we can clear this map, mp.clear. And now we'll start from here. Similarly, we have a max. This is the next max of this array. And now we'll iterate until it becomes this next max. And while all this, we will also keep on checking if the next max will decrease or not by what I showed you over here. Uh, did I? I did, but let me just do it again. Like our main frequency vector, uh, if vi is less than max, we do vi minus minus. Like we do vi minus minus regardless. But if vi is less than max and frequency of vi turns 0, so in that case, we will take next max is equals to minimum of next max, comma, vi. Because it is possible, like suppose if there is 3, 2, 1, 0, 1, 2, like 1, 5. Let's take a 5 over here too. First, we know the max of this array is 4. So let's try run what our code is doing. We'll go from 5 to 3, 5. We'll do nothing. And then what we are doing is we get to 3 and we see that since now frequency of 3 is 0 and frequency of 3 is definitely less than max. So what it will result in, our next max will be converted into 3. Okay, but now we got 2. So frequency of 2 turns 0. The frequency of 2 is equals to 0. That means the next max will be minimum of 3 comma 2. So it will be 2. And now we have 1. So we know it is not 0. We'll just do frequency of 1 minus minus. Now we get 0. We'll do frequency of 0 minus minus. And since it is 0, we get next max is equals to 0. Also, after this, you can see from here, we do not insert this into our map because we already know this is greater than max. So what we are gonna do next is we push these into the map, and as we reach this point, we see that the size of map is equals to max. Since this is max, we need to reset our array over here. So we'll just do result dot pushback max, and now max is equals to next max, that is equal to 0. And what we do is we are just clearing the unordered map. So mp dot clear. So this means from now on we have the remaining arrays 1, 5. Just a second. All right. So we have arrays 1, 5 and max is 1. So now we arrive at here. And since 1 is now less than 0, so we do not push it. And we see that mp dot size is equals to 0 and is equal to max. We again push 0, we remove it, we go at 5, we reach here, we see mp dot size equals to 0 is equals to max, we again push 0. So the result we got is 4, 0, 0. And this is definitely the lexicographically greatest because what we are doing is also using the leading. Sorry if the mic was disconnected. And what we are doing is also we are including the I mean, trailing zeros in this. So let's just code this. Should be easy to code. All right. So first we do is int n is equals to nums dot size int. I use minimum mine for max, but it's okay. Then what are the constraints? If it is 1e9, okay, it is 1e5, so we can use a frequency array. All right, we'll just initialize it as 0. Next, for int I is equals to 0, I should be n and I plus plus frequency of vi nums I plus plus. Next thing what we are doing is while frequency of max max plus plus. All right. Now the navigating the array part. So we were creating an unordered map, and we were creating a next max is equals to, currently let's assume it is n, not n actually, max. And do we have to create? Yes, we have to create an answer, int, vector int answer actually, vector int answer. So now we'll iterate the array again. For int I is equals to 0, I should be greater than n, I plus plus. If like if the number num psi is greater than max, so we can simply continue. Actually, we can decrease the frequency also, but it's of no use. But for it to be more understandable, we'll just, let's say, continue. Or this we have to do regardless. We'll do just continue. Okay, now first thing we need to check is if uh frequency of num psi equal to 0. What does this mean is this element is now missing from the right side of the subarray. And if it is missing from the right side of the subarray, definitely its max should be minimum of next max comma num psi. Okay. And our next thought would be, since it is missing from that part, but no, we are not sure. Now, if we see, if the size of map, also totally forgot to do this. We add the element to the map since it is less than max, obviously. If the size of map is equals to max, so this is the part where we break. And since we break, so what we do is we push back our answer as answer dot push back the current max, because now this is the max we could have got out of this part. And even if we extended it to the rightmost part, there is nothing we could get more of it. So max is equals to next max. And what we do is we clear the map, because from now onwards, the for map to be again equal to map dot size equals to max, these keys should be found again. So we'll found again all the keys which are less than max. And once all those keys are found, we'll again break, because that is the maximum possible value you could get, probably. Not probably, precisely. So this should be it. I think this should work. Okay, what is this? Okay, this case is wrong. Why is this case wrong? Okay, actually, we are doing this continue, and that is why we are not able to like go to this part of the leading zeros. So we'll just write the opposite. Okay, this should work. Huh? Num psi. What is the issue? That part should definitely be independent, right? Okay, so this was it. I think they should get. Okay. So this is it. Uh, I was actually able to solve three questions only, and I also got a minus in second one, which I don't remember, but I think. Let me just see. Okay, I accidentally forgot to. I just discarded the ones which are equal to it. Like if these both are one. Actually, it didn't started taking the multiples from one. I thought the factor, if any factor is equal to j, like if I is equals to, if factor of I is equals to factor of j, I thought we didn't have to take it. Actually, it was I should not be equal to j, and not factor of I should not be equal to factor of j. That was it. This was the issue. This code. Otherwise, like third was pretty time taking, I would say. Like this idea was a little late. Was also nice implementation. It's good I didn't go for the tabulation. So what I actually did code quite fast, but that too on the first try. I didn't knew that all of these were of 5 points each. Anyways, see you later, guys. Bye bye. Night.